Okay, so we're going to solve absolute value equations. All right, now to solve the more difficult kinds of absolute value equations, let's understand what the basic absolute value equation looks like and what it means to solve it. So we're going to start with a simple example. You're going to use this to help you with the others. So let's suppose I want to solve the absolute value of x equal 2. The absolute value of x equal 2. Now remember, in a course previously, not, I think it's like 3 semesters ago, when you talked about absolute value, remember the absolute value is the distance that a number is from 0 on the number line. So if you're asked what the absolute value of, let's say, -5 is, okay, so if you look at the number line, I'm dealing -5, right? So -5 is on the left side of 0, and that distance is what? 5. So the absolute value of a number is always what kind of number? Positive, unless you're taking the absolute value of 0, which is just what? 0. So the absolute value measures distance. All right, now let's look at this. The absolute value of x equal 2. So the absolute value of what number is 2 units from 0? 2 or a -2. 2 or a -2. Because what's the absolute value of 2? 2. What's the absolute value of -2? 2. So for the most part, not always true, but for the most part, when you solve the absolute value equation, you end up with how many solutions? 2. All right, so here's the idea though. So I know that my solutions are x equal
-2.
okay, -2, and the other one is x equal what? 2. Well, y'all agree? There are 2 solutions, 2 and -3. Always on your test, and you notice that on your study guide there is one problem on your test dealing with absolute value. Have that in your mind. If you can't remember how to solve an absolute value equation, have this in your mind. And so the idea is this. You see this x equal -2 and x equal 2? You see this x right here? That's that expression that's inside the absolute value bars. And all I did for these two was I wrote this number here, and I took its opposite here, right? So if this was a 5, then this would be a 5, and this would be a what? -5. If this was a 17, then this would be a 17 and a -17. It's always going to look like that. So now, using that idea, let's solve this. Absolute value of x plus 3 equal 7. Now, for the most part, somebody can look at this and tell me the absolute value of what x must be, so that way the absolute value of x plus 3 is equal to 7. 4 is an easy one. 4 is a solution, right? Because what's 4 plus 3? 7. And what's the absolute value of 7? 7. But that's the easiest one to see there. -10 would be the other. Very good. Because what -10 plus 3 is what? 7. And the absolute value of 7 is 7. Okay, so let's go ahead and actually show the work. So you can be asked to show the work though. So here's what you got to do. When solving an absolute value equation, you're going to break it down into how many equations? 2. Without the absolute value bars. So when we did this one, we said that the absolute value of x equal 2 will be what's in the inside. What was in the inside? X. So we say x equal, x equal. So x equal the other side, and x equal the opposite of the other side. All right. So over here, you can break it down into 2 equations without the absolute value bars. What's the expression inside the absolute value bars? So x plus 3 is going to equal the other side. What's the other side? 7. And then x plus 3 is going to equal the opposite of the other side, which is what? -7. And you just solve those 2 linear equations. So for us, they're going to end up being linear equations. And you just solve each one. So you can subtract 3 So what's one of your solutions? 4, which is what we said. And here, subtract 3, and what's the other? Negative 10. So when you do that in-class worksheet, I got to see the work. Okay? So make sure you write this down so that way you have an idea of what it is I want to see. All right, so that was number 1. Let's look at number 2. Number 2, suppose you had the absolute value of 3x minus 1 is equal to 6. Now that one's a little bit harder to guess because of that 3x. So let's solve it algebraically. So you're gonna take this absolute value equation, you're gonna rewrite it as 2 equations without absolute value bars. So the remainder is not gonna have absolute value at all. So you're gonna write it as 2 separate equations. So what's your expression?
3x minus 1 equals 6.
Okay, so then you're gonna say 3x minus 1, whatever's inside the absolute value bars equals the other side. What's the other side?
3x minus 1.
So, no, what's the other side? 6 is what I want you to say. And then 3x minus 1 equals a what? Negative 6. So think about the number line from the number from 0. So the absolute value of x equal 2. You went 2 units to the right and then 2 units to the left. So that's why you use 6 and negative 6. And so notice I went from an absolute value equation to 2 what? Linear. Okay, so what's the next step? Add 1. So 3x equal 7. And so therefore x equal what? No, not negative 5. 7/3, right? Divide both sides by 3. Over here, add 1. 3x equal negative 5. But what's x? Negative 5 over 3. So your 2 solutions. And you can check them if you want to. Let's just check the negative 5/3 just to show you what it looks like. So if I check this one, check x equal negative 5/3. You go back to the original problem, that's the one with the absolute value bars. And wherever we see the variable x, what do I plug in? Negative 5/3. So I get the absolute value of 3 times the negative 5/3 minus 1. See that 3x minus 1? And I want to see if that's going to equal 6. All right. What is 3 times negative 5/3? Negative 5, because the 3's divide out, right? What's a negative 5 and a negative 1? Is the absolute value of negative 6 equal to a 6? Yes. Okay, so it works out. That's number 2. Let's look at number 3. Number 3. All right, number 3, you have 2 times the absolute value of 4x plus 1 equal 8. 2 times the absolute value of 4x plus 1 equal 8. What is the difference between 3 and the other 2?
It's got number.
Okay, so in front of the absolute value bar, you have a 2, right? You're multiplying by 2. You agree? All right. So what we're going to do, remember before I split them apart, when I split them apart here, what was that number in front of the absolute value bars? 1. Now don't distribute, because if this was a negative number, distributing is going to give you an error at some point. The only time you distribute is if these were, instead of absolute value bars, those are what? Parentheses. Those are not parentheses. Okay? So be careful. You only distribute if you're dealing with parentheses raised to the first power. So the first thing you're going to do is divide both sides by 2. I'm going to write it over. Divide by 2, divide by 2. 2 divided by 2 is 1, right? And 8 divided by 2 is what? 4. So I get the absolute value of what?
4x plus 1 equals 4.
All right, very good. Now it looks like the other 2. All right, what's the next step?
break it down into two different equations.
Break it down into two equations without the absolute value bars, without the absolute value bars. So what's your first equation?
4x plus 1 equals 4.
What's the other?
4x plus 1 equals negative 4.
Y'all agree? Okay. So notice I went from an absolute value equation to two linear. So let's solve each one. So in the first one, the one on the left, you're going to subtract 1 from both sides.
Mm-hmm.
So I get 4x equal a
3.
3. So what's x?
3/4.
3/4. There's one of your solutions. Over here, subtract 1. I get 4x equal a
Negative 5.
negative 5. So x equals a negative 5/4. So those are your two solutions. Okay, number 4. All right, number 4, you have 3 times 5x minus 6 minus 7 equal 2. 3 times the absolute value of 5x minus 6 minus 7 equal 2. So if you notice the procedure from the other 3, when before I split them apart, what was by itself?
Just a minute.
The absolute value bars. So before you split into two separate equations, you got the absolute value bars by itself. What do you think you're going to do first? No, I wouldn't divide by 3 first. I'd add 7 first. Add 7 first. So I get 3 times the absolute value of 5x minus 6 equals a 9. Then do what?
Then divide 3 by both sides.
Then divide both sides by 3. I'm going to go ahead and rewrite this over. And
5x minus 6 equals 3.
so absolute value of 5x minus 6 equal 3. Make sure you put the absolute value there. So notice that, notice at every point I had the absolute value bar still there up until I split it. Once I rewrote it, then I no longer had the absolute value bars. So when you work on the in class, some of you are going to mess up at that point, and I'm going to explain why it's not correct at that point, whatever you put. Because here's what some of you are going to do, and I want you to understand why it's not correct. Some of you are going to do this. You're going to go from here, to this, and you're going to say this, 5x minus 6 equal 3. And then you're going to split it apart. You're going to say 5x minus 6 equal 3, 5x minus 6 equals a negative 3. But that's not correct. Because that is just a linear equation. That is not a what? Absolute value. If you're going to split it apart, then you better have what right here? Absolute value bars. Okay? So I've seen people do that. They'll go from this part here, from this part, they'll write this, and then I'll see these two segments. You're not going to get full credit. It's not correct. Mathematically, it's not correct. You got to have this. Then you split it apart. All right, so what do I write?
5x minus 6 equals 3.
Yeah. All right, a couple more steps and you're done. So what's the next step?
Add 6 to both sides.
So 5x equal a,
9.
so what's x?
9 over 5.
Okay, there's one of your solutions. Over here,
Add 6 to both sides. You get a 3.
so what's your solution?
3/5.
3/5, so there's the other. Okay? All right, number 5. Number 5. Suppose you had the absolute value of 2 minus 7x equal 3. 2 minus 7x equal 3. Notice the absolute value bars are already by themselves, all right? So what's the next step? Split them into two separate equations, two linear equations. So 2 minus 7x equal a
Positive 3,
positive 3, and the 2 minus 7x equal a
negative 3.
negative 3. And then you solve each linear equation. So in the first one, what are you going to do? Subtract 2. So I get a, not 7x, but a what?
Negative 7.
Negative 7x equal a 1. And so therefore, what does x equal? Divide both sides by negative 7. I'm going to go ahead and rewrite it.
Negative
I'm going to actually divide by negative 7. So what you do one side, you do the other, right? So negative 7 divided by negative 7 is 1. 1 times x is x, but that's equal to a negative 1/7. The next one, subtract 2. Combine like terms. I get 7x or negative 7x? Negative 7x equal a
Negative 5.
negative 5. Then divide both sides by negative 7.
Get a positive 5 7.
Yeah, because a negative divided by negative is a positive. So those are your two solutions, negative 1/7 and positive 5/7. Okay? Now, remember that in one of the problems, I checked one of the solutions just to verify it was correct. Y'all agree? Remember that? I just did one of them. I think it was right here. I saw that? Okay. So if you check all of them, everyone we've done so far, if you check them, they work out. Now let's look at this. I just want to show you something. Pretty much. The absolute value of, I'll make it easy for you, x plus 3 equal negative 5. The absolute value of x plus 3 equal negative 5. What's going to happen is that some of you are going to go and you're going to split up in two separate equations, and logically that's what you do because that's what we've been doing, right? Okay, so let's do that. So I'm going to split it up in two separate equations, and you're going to say x plus 3 equal what? Negative 5, and x plus 3 equals a what?
5.
Positive 5. Okay? And then you're going to solve each linear equation. So you're going to subtract 3 from both sides, and you're going to get x equal what? Negative 8. Subtract 3 from both sides here, and you're going to get x equal a positive 2, and you're going to go from there. You're going to say, those are my solutions, I'm done, right? You're going to lose a lot of points. Let's check them. Let's check negative 8. What's in negative 8 plus 3? Negative 5. What's the absolute value of a negative 5? Is 5 equal to negative 5? No. That's not a solution. Let's check 2. What's 2 plus 3? 5. What's the absolute value of 5? Is 5 equal to negative 5?
No.
That's not a solution either. So you can think of those as extraneous solutions. I've exhausted my proposed solutions. So what's the solution to the equation?
No solution.
No solution. So this has no solution.
Are you going to hit us with anything?
Yeah, it's on my math lab.
What
It's
about
on your worksheet. But here's the idea, guys. The absolute value of a number is either going to be positive or what? 0. Can never be what? Negative. So if you get to a point where you have the absolute value of an expression equal a negative number, then right away say what? No solution. You don't have to do all this work.
Okay.
You don't have to do all that. So in all the problems we've done, though, we had solutions because I had the absolute value of an expression equal what kind of number? Positive. So those were going to have solutions. Those absolute value equations would have solutions. Here you can't because you remember the absolute value of whatever this is measures the distance from 0. And that distance must be positive or 0. It can never be negative. So once you get to that point, you say no solution. You don't have to do all this work. Let's do number 7. The absolute value of 2x plus 5 equals 0. In all the problems we've done, except for the number 6, how many solutions were there? 2. There were 2 solutions. Because when we wrote it, we said the absolute value of that expression equal number. We went 2 units, we went that number of units to the right and then that number of units to the left. But that's a 0 right here. So the best thing to do is this. If you think about splitting it up, it's not going to make really any sense because look what happens. 2x plus 5 equal 0, and then you're going to say 2x plus 5 equal 0 again. They're the same equation, right? So just do one of them. So how many solutions will end up if that's a 0 on the other side? How many solutions will you have? Just one. Just one solution. So subtract 5. I get 2x equal -5. So what's your solution? -5/2. That's your solution. You just get one solution. Okay? So that's absolute value equation. That's all I wanted you to learn there. That's absolute value equations. Okay? Just remember though, once you get the absolute value by itself, and if this is negative, you can automatically say no solution because the absolute value of a number is never negative. And if this is 0, just write it once. Okay, any question at that point? Yes.
If it's a negative 5/2, like a negative fraction, it's still a solution?
Yes.
Okay.
Yeah.
You said no negative.
What now?
Cause like -8, -2.
Well, that's because this was negative on the other side. You can't have, the absolute value of a number can never be negative. But the absolute value of a number can be what? 0.
Alright, thank you.
Because the absolute value of 0 is what? 0. So if I substitute -5/2 back here, watch. Let's check -5/2. You go back to the original. The absolute value of 2 times x, what's x here? -5/2. Plus 5, absolute value, and I'm checking to see if that's equal to what number? 0. The 2's divide out, right? You agree? What's -5 plus 5? 0. Is the absolute value of 0 equal to 0? Yes. All right. Okay, so that's going to take care of this part.